What do trees know? What material properties, what agency does wood have whenever you're working with it as a sculptor? Wood was once alive and had a lot of material agency. Trees grow according to their own logic. But by transforming it into lumber, we often take away the plasticity of wood, its own internal logic that allows it to bend and flex in different conditions. So wood bending as a process is about bringing that ability back to the material, to allow it to become plastic again. Sculptors and designers have often used wood bending as a way to balance the human desire for order and the desire of trees to respond to external stimuli and pressures. The process of wood bending allows an artist or designer to think about wood not as a dead, lifeless material to give order to, but as a collaborator, as something that has its own material properties that we can embrace and utilize for certain ends. My name is Michael Webster. I'm an assistant professor at Wofford College. I teach studio art with an emphasis in sculpture, and also teach furniture design. Wood bending is something I've been teaching for years as a process that's really integral to thinking about wood as a sculptural material. It allows you to push the limits of what's capable with the material and create forms that are far more fluid, lyrical, and beautiful than you might achieve through simply straight, square cuts in lumber. This demonstration will include 4 different types of wood bending, from steam bending to laminate bending, kerf bending, and also hot pipe bending. And throughout those demonstrations, I'll introduce a variety of artists who are using those for various creative ends. So to start this journey, let's look at a few artists who are really pushing wood bending as a sculptural and design process.
Natalie Jeremijenko created this work at Mass MoCA, where she's hung a series of trees upside down and allows them to bend in response to external stimuli. The trees actually turn and start to head upwards in response to gravity and to light over time. And she's titled the work Tree Logic because she's embracing this idea that trees have their own systems and their own logic and their own knowledge that they can respond to the environment and actually shift their own shape in that process. Martin Puryear is perhaps the most well-known artist who uses wood bending in a contemporary context, and he creates a series of abstract sculptures that have remnants and pieces of familiar cultural forms or familiar utilitarian forms, but are utilized for metaphorical or psychological impact. Alicia Quade produces work that transforms our expectations of materials and materiality, as well as time and space. Wood bending becomes a process to help us consider our perception of the world. Of course, wood bending in design was made famous through the toenet chair of the 1850s, and now has been utilized more recently by Charles and Ray Eames in bent plywood chairs, which were developed after World War II while they were developing leg splints. So the leg splint design ultimately led to innovation with furniture design. Let's jump into the 4 demos, and I've divided them up into 4 chapters in this order. Hot pipe bending is one of the simplest methods for bending wood. In this section, I'm going to explain the methods and process for doing hot pipe bending using this contraption that is in the image here, and you get results similar to this. Historically, hot pipe bending has been used most commonly by luthiers building guitars or other musical instruments. So the first step is to rip your material down to size. Typically, I shoot for about an 1/8 inch thick piece of material, and I prefer to use the table saw for ripping this material, but you can also use the bandsaw. Whenever you're using the table saw to rip a thin piece of material, it's important that you are pushing the bigger mass of stock between the blade and the fence. So that way you're cutting the small, thin strip off on the outside of the blade. This allows you to have more control over the material and is a much safer process. If you try to move the fence close to the blade and cut an 1/8 inch between, you can't really carefully push the material through. So here what I typically recommend is if you have an accurate gauge on your saw, then you can actually move it over 1/4 of an inch every time you want to make an 1/8 inch cut, and that will account for the 1/8 inch thickness of the blade as well as the 1/8 inch thickness of material. I've also had a student who's cut into the fence by trying to cut a small piece off. So you prepare your material for hot pipe bending by soaking it in water for a few hours, and you'll turn your gas on a very low setting and give it a few minutes and it will heat up the whole pipe. You'll know that the pipe is hot enough to start bending whenever the water sizzles on top of the surface. So right now I've got this piece of walnut here, and as I press the walnut into the pipe, the water helps the heat move into the lignin, which is, right now you're seeing the chemical structure of lignin, essentially a polymer similar to a plastic that's within the wood that makes up about 30% of its mass, and that's what bonds the cellulose together. So you're melting this polymer essentially like a plastic to allow the wood to become soft and malleable. And it will start to hold its shape. It will have a little bit of spring back, but it's a great process for quickly being able to manipulate and bend wood in a variety of shapes. Here I'm creating a spiral shape. And one thing I forgot to mention is you definitely want to wear gloves for this process. As you can see, I'm wearing a pair of leather gloves that will keep me from burning myself. The pipe will heat up to a pretty high temperature and will not be forgiving, so you do not want to try this without gloves on. Hot pipe bending is not used heavily by artists and designers, but one artist who uses similarly scaled pieces of bent wood is Bar Gantz, who is an Israeli furniture designer who, you can see from the image, created this mirror and this shelf using very simple twists in small pieces of lumber. Wood bending is an excellent way to think about the beauty of a single gesture, or the impact of a single gesture, like a single twist in wood, and how that can become something that's transformative to a material that we don't expect something to be that lyrical or that fluid. This particular bending jig uses a 1-inch black steel pipe, but you can also use a 2-inch black steel pipe for larger circumferences, which is what you see me using in this case with a different bending jig. Many people prefer to use a vice clamp like this to hold their pieces of wood so that way their hands don't get too close to the hot iron. In this case, you can also see a failure that I've had where the grain of the wood is not that straight, and so what happens is as it's bending around the form, you get these fractures and these breaks in the wood. Another failure you might have, which you're about to see, is if you get a piece of wood with a grain that's really at an angle, it's going to snap quite quickly, and you're not going to be able to get any bend. I'd like to show you how I built this particular bending jig, and so we're going to look at the details and the step-by-step process of that. So the jig is powered by a propane torch that you can buy from any big box store, and the nozzles on those are usually set at 150 degrees of a bend, and so that means that we're going to have to build a 40-degree angled piece of material that's going to hold the bottle at the correct angle in relationship to be able to go directly straight into the pipe. And since propane is problematic to breathe in over a long period of time, make sure that you're in a well-ventilated space so any propane that doesn't burn off coming through the torch is going to be blowing away from you. And you'll notice that this element, this little cradle that's holding the propane bottle, is its own separate element. I prefer to build jigs so that way they're adjustable or reconfigurable in the future. So this particular bending jig has a couple different parts that are screwed together that can each be disassembled and then reassembled later in the future in case I have a different size bottle or something about my use of the tool changes in the future. So right now I've cut the angles on the bandsaw and I'm sanding them down flat at the moment. And then I'll assemble all the pieces with just screws. That way if I ever need to change the angle I can just replace those pieces of wood. Roxy Payne is an artist who creates wood illusions of current contemporary environments. In this reproduction of a TSA terminal, you can see that he has used something similar to the hot pipe bending method to create those very small bent elements of the flaps going under the x-ray machine. Or here, whenever you can see the little tubes that bend around connecting one part of the machine to another. His work uses mimicry through wood as a way for us to look past surfaces and look past materials, but to see objects and spaces as elements in a system, or in the creation of systems that produce facades and produce images. And so in this case, for example, he's created an entire diorama of a fast food restaurant. So you're looking into a diorama that's kind of representative of this illusion that's created for fast food consumption. Heading back to the build process, you can see that each of those screws are countersunk on the first part because we're going to be attaching that and we want a nice flat surface to be able to attach that cradle to the L shape of the wood that's going to be resting on the table surface. I attached the primary vertical and horizontal piece within this jig with the dado, and I actually glued that part because I assume that I'm not going to take apart this particular 90-degree angle, and so I'm going to cut a dado here. I'm not going to use the dado stack because I don't want to switch it out to just cut the single dado, so I'm going to make multiple passes on the table saw using the table saw sled to clear a pathway that's wide enough for this 90-degree connection. You want to ease up to the correct width and not cut too much off because you want a nice snug tight fit on any dados, and this fits really well. So now we're going to take some glue and we're going to assemble these two pieces together. You can see I've left about an inch hanging off at the end. The reason is we're going to use this little edge like a bench hook. We're going to hang the bending jig over the edge of the table, so whenever we're pressing down and back hard up against this bending jig, it can't slide backwards onto the table further. For building a jig with a 1-inch steel pipe and a floor flange that matches that, you're going to want to drill a 2-inch hole with a Forstner bit that will line up with the location where the nozzle of the torch is going to intersect with the vertical face of the jig. Once you've drilled the hole for the torch to go through into the pipe, you want to go ahead and anchor the pipe to the vertical piece. So you're going to mark where each of the holes are going to go, and you're going to run bolts through that to be able to tighten it down really well, and it also makes it very easy to disassemble later on if you need to take these apart later. So this will be the only part of the jig that I'll glue together, and that allows me to have more flexibility if I decide to reconfigure this jig later on, but it needs the strength in this one particular area. When you are placing your clamps, make sure that you check and double check that the two boards are interacting at a square 90-degree angle, because it's very easy to put pressure in the wrong spot and to bend those boards out of square. I could also use a corner clamp that would help with aligning those two boards together, but the dado helps a lot already, so I can just tweak the location of the clamps to get them square. The scale and the speed of hot pipe bending is really great for iterative thinking and thinking through process, essentially making three-dimensional sketches. And you see that here with the artist Joseph Walsh, who creates monumental-sized wood-bent sculptures, but in this case he's creating a small form to think through the bends and the curves and the interaction of negative space for a larger form. It's quite easy using this process to bend dozens of pieces of wood within an hour, so that allows you to think through ideas relatively rapidly. Here you can see some of Joseph Walsh's larger sculptural works. He's also a furniture designer as well, and his larger sculptural works really take that single gesture that you can get from something like a small bent piece of veneer, but amplify those up to the scale of architecture. As we get closer to wrapping up this build video, you can see that I'm screwing the cradle into the L frame here, both from the front and from the back, and that adds a reinforcement to make sure that we don't put stress on this L frame and break it. I've made this little angled block that will work as a base or stop for the torch, and by screwing this in, I can also adjust where the torch is incrementally by moving the block backwards or forwards. That's going to change the height and how far it protrudes into the pipe at the same time. Our final step will be to create some kind of strap that will hold the tank in place, because we don't want a compressed air tank to be able to tip off and fall over or something like that. So this strap, I'm just using strapping that you can get from a big box store for hanging plumbing pipes in your house. I think hot pipe bending is a great way to start to introduce students to thinking about different ways that you can bend wood, or really any beginner just to get them started. And that's all I have for hot pipe bending, and I hope that was informative. And we'll move on to the next section. This section is about steam bending. So I'm going to show you how to create this particular steam bending box, which allows you to heat up your material and inject it with a lot of steam, and then you're going to be able to bend that material in a variety of different ways. First thing is, safety-wise, the steam and the steam box is going to get very hot, so be careful opening the front door. And I'm sliding out a piece of material that's about 1 inch thick. So for each inch of material, you're going to steam it for an hour. This process puts a lot of stress on the exterior edge of the material. So you have to use a spring steel strap that you're going to strap around the material. So as you're bending it in, that compresses the wood on the outside and keeps it from failing. Another important component is the form that you're bending the material around. So in this case, I've already got a pre-made 34-inch radius curve, and I recommend trying to work with a partner because you have to put a lot of force into the lumber to be able to bend it whenever you're steam bending. An artist who uses steam bending exquisitely is Yuri Kobayashi, who's a Japanese woodworker living in the United States, who builds furniture and also sculptures. You can see this chair where she's used bent legs very gracefully and bent back railings. And then also, this is part of a larger installation, these little interlocking bent forms that then spread out over the entire gallery space, creating this larger installation that meanders through the gallery. You can hear cracking from the steel compression strap, keeping the wood bound together. So it wants to expand outwards and break, but by having that steel compression strap, the wood has nowhere to go but to bend. And this is where you can find the steel compression strap. It's very important that the stop blocks on the either end of the steel compression strap are at the length of the piece of lumber, because if there's any wiggle room, that's going to cause problems. So for me, because I didn't get the adjustable one, I make little blocks that fit in between the stop block and the end of the piece of lumber, and I can adjust the size of those. You'll notice the last couple inches of a piece of steam bent wood will never bend. They're always going to stay straight. That's just a fact of steam bending, so you have to account for that whenever you're measuring out whatever kind of curve you want to end up with. Plan for a couple inches on either side that you're going to be cutting off. I'm sure you've noticed that the handles also overlap the piece of bent wood by about 1 foot. The handles need to go beyond the stop block and overlap the piece of lumber that you're bending to keep the steel strap from kinking. Steam bending also requires careful selection of lumber. You want quarter sawn lumber that is air dried ideally. Most lumber is dried in a kiln, and it'll bend somewhat, but you're going to get the best results with air dried lumber that's been quarter sawn. So look at the grain and try to find a lumberyard that will carry air dried lumber for the best results. After drying overnight, you can see there's a little bit of spring back, and there's also staining from the steel strap on the piece of lumber. The staining is an unavoidable aspect, and you can see the sculptor Richard Deacon allows the staining to remain on the wood rather than sand it off. But a lot of artists choose to sand off the staining that's left over from the steel straps. Deacon is a well-known British sculptor who utilizes steam bending in a lot of his projects. So here's 3 different approaches that he's taken to thinking about utilizing steam bending within abstract sculpture. This work utilizes twisted pieces of lumber, so let's delve into that process. I've started by steaming a piece of square stock for about 2 hours, and I've got 2 places to clamp this material on either end. One, I've got a drill press vise, and on the other end I'll clamp it to the column. This process requires a lot of leverage to be able to twist the piece of wood. You can't do it with your bare hands. So I'm going to take a 2x4 and I'm going to create a square hole within it by drilling out some of the material and then using a chisel to chisel out a square hole. That hole needs to fit relatively tightly over the end of the board, and that will give you the leverage to be able to twist it into the shape you want. This particular piece of stock had a failure in the middle halfway through, so I was only able to turn it about 110 degrees, but you should be able to get closer to 180 with a board this length if you're using the proper lumber. That gets onto the point of what species of lumber should you be using for steam bending. Some of the best lumber is white oak or ash. Those are the woods that are typically associated with steam bending the most, but sometimes you can get away with other lumbers as well. The single most important thing to think about with lumber, though, is you want something with no imperfections like knots, and you also want lumber with very straight grain. Swirly grain or diagonal grain will cause failures almost immediately with any type of bending that you're trying to do. So you can see here the amount of twist I was able to get in this particular piece, and because of the failure, it twists more in one area than the other. Small thin pieces of lumber will steam bend relatively easily without a compression strap and without necessarily using a form. I created this little jig so that way a bunch of students in my classes could free form bend small pieces and leave them in place. This doesn't require any clamps, and also we can move the grate afterwards, or this jig afterwards, if we want to get it out of the way. So here I'm bending a few pieces. We're about to see a failure where I overbent a piece. So once you get used to the process, you'll start to feel whenever the wood's going to give up and you can try to stop in time. But any wood bending is going to have failures occasionally. So you just have to know that that's part of the process, and it takes some experimentation and some luck and some experience to start to understand what's possible with the material. Since I'm bending them by hand, it's a little bit imprecise compared to using a form, but you could very quickly make lots of bent pieces using this technique. As I start unclamping them, you'll see that they don't spring back too much because they're smaller. They're just going to spring back a couple degrees and that'll be it. And we can't talk about steam bending without talking about Matthias Pliesnig, who creates these amazing sinuous benches, very sculptural in form, but also functional as seating. And I find it fascinating that all of his work is a grid that's been pushed and pulled like a piece of clay, so now the grid is deformed like a black hole in space-time. So now we're getting on to the build phase, where I'm going to show you how, if you want to construct your own steam box, how I've constructed mine, and you can follow this process step by step if you'd like. The first thing I've done to prepare here is to cut a total of 6 pieces, 4 sides and 2 ends that will cap the steam box off. And what I've done is I've clamped the 2 sides together and I've labeled which is the top side of those 2. I'm now marking out all the locations for what's essentially going to be the shelves on the interior of the box that are made out of dowels. So we're going to drill holes and we're going to put dowels from one side of the box to the other. The reason for this is that we need air to circulate around the piece of wood in the steam box. By clamping both sides together, I can drill holes that will definitely align from one side to the other. Once I've drilled all the holes on the drill press, then I can start assembling the box together. I want to start off putting the 4 sides together, and I'm using a corner clamp here to help hold it in place while I put screws. I'm using cheap 3/4 inch plywood. We're going to be filling this box with steam, so we don't need any expensive or fancy plywood. I'll also add a few small holes on the bottom of the box to act as drain holes and also to make sure that the box doesn't become pressurized. This is the hardware I'm using. I'm using hinges and a clasp for the door that will open and close, and this specific bushing and nipple will be utilized to be able to attach the hose from the steamer to the interior of the box here. A wallpaper steamer for about $50 is a great way to make sure that you can heat up your box consistently. One wallpaper steamer is all you need to heat up a box that will hold 4 feet of lumber, such as this box. I've also got a longer 8-foot long box, and that I hook up 2 steamers to it to make sure that I get enough steam to really saturate everything. I've also built these rather large because I have a whole class that will use them at the same time. Here I'm gluing the bushing and the nipple and the washer into the box using some construction adhesive. And I'm setting a stop block on the miter saw so I can cut all of my dowels to the exact same length quickly. I'll bevel the end of each dowel on the sander after this so that way each one will fit into the holes in the box much easier. One thing to note is the spacing for the location of the dowels. You want to make sure that you keep all the lumber off of the bottom of the box to allow air to circulate. You also want to consider that most of the steam is going to collect at the top of the box. So you want to put your dowels at a location where it's going to keep the size lumber you want near the top of the box but still allow air to circulate. So I've placed a row of dowels about 1 inch off the bottom of the box, and then I've left 3 inches of space between the rows of dowels as we move up. That will allow me to put a piece of lumber in there that's 2.5 inches tall and will allow air to circulate through it. So we'll attach the front door with hinges and a latch so it can easily be open and closed. You want to put the hinges on the bottom so that way the door will stay open if you want it to stay open. You can also add foam weather stripping around the edges of the front if you want to create a more tight seal. I'm going to stop talking for a second so y'all can listen to those sweet, sweet construction sounds. The next step is to add the legs. Because the steam comes up from the bottom, you've got to have legs on the box. That way the hose can enter the steam box from the bottom. It also allows you the opportunity to add drainage because if you build the back legs an inch taller than the front legs, water can run down and out through the crack in the front of the box. If you've done much work with wood before, you know that moisture and heat can cause a lot of warping over time. So I created an entire square around the box that works as a strap to contain the box. Over time, with all the heating and cooling and the moisture and the drying, your plywood box could start to want to come apart or warp a good bit. So the legs and the square that wraps itself around helps reinforce those corners and those joints despite the consistent changes in temperature and humidity. And that's one way to build a steam box. The term laminations is a synonym for gluing together multiple pieces of lumber. So bent laminations is using thin pieces that can make a certain curve individually, and gluing multiple of them together to create a larger piece that couldn't bend that far by itself. So in this case, I'm starting off with one piece of walnut that I'm slicing into a variety of thinner strips so I can make a much quicker curve. By laminating multiple pieces together to create a bend, you create a pretty strong and also really consistent bent form. So here we're going to use Typon 3, which is a wood glue that has a little bit longer open time. And the benefit of the longer open time is that wood glue starts to dry very quickly. And if you're gluing up multiple pieces together, you're going to have a problem with the glue starting to set before you've gotten everything in the form. So by using Typon 3, we actually have an extra 5 minutes or so of open time. I'm laying out all of the different laminations together here in the order that they're going to be assembled, and I take one lamination and move it off to the side. We don't want to apply glue to one of the pieces here. You'll also see that I'm spreading the glue with a brush. You can also use a rubber roller, but you want to be able to spread the glue quickly over the surface and evenly. If you have large pockets of lots of glue and then voids without glue, then you're going to end up with a really sloppy result. So once I've spread the glue evenly over the entire surface, we're going to now place all the pieces on top of each other, and we're going to place them into our mold, or our bending form in this case. I've pre-made this bending form out of two pieces, a particle board that's covered with a laminate on the top, and I've screwed those pieces together so that way they're at least as tall as the wood that we're bending. You don't want your bending form to be shorter than the wood that you're assembling together. One of the best furniture designers using bent laminations is Laura Kishimoto, who creates a variety of seating using bent laminations that also then come apart in certain areas and create voids and negative spaces. And that generates a lot of really interesting repetition. Since I'm not showing the process of creating the bending form here, the white part of this project, it's really important to note a couple things. First is that whenever you create the bending form, you want to cut away and leave negative space in the width of the laminations you're going to be gluing up. So in this case, I've got a space that's about 3/4 of an inch of negative space between these forms, so that way I'll get a nice even pressure whenever we actually glue up all these pieces. You'll also notice that I have some registration lines drawn on there. So if I know those lines are aligned with one another, then the form is coming back together as it was envisioned. As I demold this particular piece, you'll notice that it has a very direct relationship to the mold itself. You don't get any spring back with this process. So moving on to how to clean up this particular piece, you're going to do it on the bandsaw, trim the edges. very carefully, and then use a hand plane to smooth each edge afterwards. While you're watching me cut this, I'd like to introduce another artist. This is N.K. Kuo, who is creating these really magnificent architectural design features using logs that he's slicing up into pieces, bending with steam, and then bolting them together to hold them together in lieu of using glue. So he's doing bent laminations on a massive scale, including steam to help get further bends that he couldn't achieve other ways, and then using bolts as a substitute for glue in this case. So he's doing large architectural projects and retaining the look of trees while he's doing those. It's a really unique and innovative way of using wood bending that I haven't seen replicated before anywhere else. So as I finish this cut, you're going to see me start to work with the hand plane and smooth the faces. This is probably the best way to clean up the saw marks you get from the bandsaw. My hand plane's a little dull at the moment, and so you'll see it kind of skipping around and being a little tougher than usual. I've also seen people clean up laminate bends like this on the table saw, but you have to really be careful about that because it's a little bit of a sketchy process. So to show you another way to achieve bent laminations, here I'm cutting up a bike inner tube, which I'll use as a clamp, and I'm going to wrap that around my laminations whenever I just put the glue on, and that allows me to free-form laminate bend pieces together rather than have to build a rigid form that I'm going to use to bend my laminations. So I've got 3 pieces of thin pine here. These are just scrap pieces that came off of some boards at some point. And I'm applying glue, and then I'm going to wrap the inner tube around, clamping on either end, and then that will allow me to just bend it as I see fit. The rubber in the material of the bike inner tube doesn't stick to wood glue. So as I'm wrapping this around, it doesn't matter if I get wood glue everywhere, the bike tube will come off easily once the glue has dried. This process is relatively fun during the bending phase, but then you do have a lot of cleanup left over at the end because you do get wood glue all over the surfaces here. So you do have to spend a significant amount of time sanding and cleaning up your material afterwards. I didn't go into this process with a plan, so you can see I'm just trying to see what shape I want to bend the form into and what might be possible with the thickness of the laminations that I'm bending together. With any laminate bending, the amount of curve you're able to achieve is going to depend on the thickness of the laminations that you've cut. So thinner laminations, something like veneer that's very thin, is going to give you very, very tight radii that you'll be able to bend. And I'm really trying to get the maximum out of this particular piece at the tightest curve. You'll see that I took another bent form and I've clamped it to the laminate bend so that way I can get a double curve. So I can get a little variation in the way that this curve is actually moving through space. So you can really just make stuff up while you're doing this process and see what happens. It's a more exploratory, experimental process. And our last process is going to be kerfbending, which is where you take a piece of plywood, you make a series of cuts that are spaced evenly, and those cuts allow for more flexibility in the plywood than you could achieve in a solid piece of plywood. The first step of kerfbending is to find a way to make repeated cuts that are spaced evenly so you can get an accurate, even curve throughout the surface. In this case, I'm using a table saw sled, and I've clamped a sacrificial fence to the sled. This will allow me to, you'll see I just took out a little key, and that key is made out of an 1/8 inch piece of masonite that I've cut that I can fit into a groove in the sacrificial fence. You'll notice in the fence now there are 2 slots, and I'm going to place that little key into one of the slots, and that will allow me to register each new cut based on the previous cut. So I'll get even spacing from one cut to the next every time. Kerfbending is used most commonly by furniture designers, but this artist Nukarin from Thailand I'm not going to try to pronounce her last name because I couldn't find a pronunciation that was correct. But she has made these little experimental sculptures, these little gestures that are made with very accurate kerf bent cuts that have been re-glued together. And she's exploring the potential of kerf bending for gestural form. And you can see with a series of cuts now, we've got a 90-degree curve. And it's important to try to make this curve close. So all of the little pieces that are left between each of the kerfs touch each other at the end. So whenever you apply glue to the surface, and here we're going to use two-part epoxy, because two-part epoxy will fill any voids and have a high strength, whereas if we use wood glue, it has no strength if there are voids. And so we're going to use two-part epoxy here, and we want to make sure that each of those ribs that are in between each of the kerfs are touching each other so that way they close this form. To be honest, I screwed up the video of the first demo I did, which was correct, and I rushed through the second one, and then I didn't actually check how accurate it was, and I added an extra kerf here. So it's actually staying open whenever I bend this at 90 degrees instead of all closing and coming together. To fix this, you would want to let it dry and then add more epoxy until it fills in that space, but you'll have to re-veneer it to hide any of those voids. This dried example was my first one, and it is correctly produced, and you can see it has a high strength because of that epoxy. So the next step is to cover all of the edges with edge banding. I cut my own edge banding typically, especially for something like this, because I want to be a little thicker and provide a little bit more strength. I'm going to tape off areas so I protect the veneer of the plywood from getting glue all over it. And then I'm going to glue, first of all, this little corner piece. I've cut it at a 90-degree angle, so that way whenever I apply it at 45 degrees, I'll have a square edge on either side. And for this part, I'm just using standard wood glue because I have a strong bond surface on surface. I'm using a square to make sure it's applied correctly and then clamping it in place. Once it's dried, I'll be able to cut it with a handsaw and then apply the other two pieces and then use a router to clean up any overhanging edges from the edge banding. And the final step is using a stationary router with a trim router bit to trim off any excess material and to make sure that the edge banding is flush with the surface of the plywood. Once this has been achieved, then I can do a little bit of sanding and then put finish on the surface. And this is it for the wood bending demos. I hope you all learned a little bit and enjoyed seeing me go through these processes and are able to maybe utilize this in your own artwork. Thank you for watching.